Today we are going to continue with the topic on wave data analysis. Previously we have been using the wave records obtained from view measurement, whether it is carried out near the coastal area or in the offshore region. Specifically, wave data in offshore region is collected typically by ships, by vessels that travels around the world. For example, in this slide we see a grid whereby as ship companies travel and they are located at a particular grid, what they typically do is that they will take the reading of the wave as well as the wind, including speed, direction, and for wave magnitude, and record it down. And all these are sent to an international organization that compile all the observations in order to give us the offshore or deep water wave condition. This collaboration around the world is known as the Summary of Synoptic Meteorological Observations. Other than the direct observation of waves, as mentioned, whether it's done in coastal area or in offshore region, observation of wind is one of the most important data because waves are generated primarily by wind forcing. So wind data which has been collected typically will be analyzed and presented using what we call a wind rose, which gives a view of how wind speed and direction are distributed at a particular location. This is an example of a wind rose. The observation may be from a light tower, it may be from data consolidated from offshore observations. Here we are going to look at how we read and understand the information contained in a wind rose. For example, in this case, the wind rose show that for this particular location, there is a certain percentage of time whereby the wind is essentially calm, which means there's no wind. Over here we see the value inside the calm region is 0, which means that in this location it has not recorded any particular time whereby there is no wind. So the wind speed has been broken down into these categories, as we can see, from 0 to 5, 5 to 15, 15 to 25, and larger than 25. So what we see here is that they are concentric circles, which give us the frequency. We notice that for this particular circle, it is 56%, which means that there are 56% of the time the wind speed range between 5 to 15 miles per hour and is blowing from this direction. Meanwhile, this is 72%. Okay, just now it was 56, so from 56 going up to 72, there's another 16%. So 16% of the time the wind is still blowing from this direction, but the wind speed is in the range of 15 to 25 mile per hour. So as we can see in this particular case, for this location, the wind direction is very uniform. It seems to be always blowing from the west. Of course, there are some other time whereby the wind blow from this particular angle, but that is only about 24% of the time, and less than 8% of the time the wind is blowing from this angle. So this is how we read the wind rows, which give us information about the distribution of the wind speed and the wind direction. Whether it's wind rows or wave rows, the concept is exactly the same. Here we see wave rows instead of wind rows. So if you look at this particular figure, you notice that in this particular location, 26% of the time it is calm. And we need to be careful how we define calm. Notice that there's a legend here where it says significant wave height. Okay, white color represent below 0.1 meter. Okay, so if the wave is less than 0.1 meter, that's very small, that's literally negligible, so we call that calm. So 26.1% of the time in this location the wave condition is calm. And as the wave goes above 0.1, you see there are different range here represented by different color. So we can read from the wave rows, okay, the direction of the incoming wave. Right, we can see that the wave seems to come predominantly in the northeast direction here, or the southwest direction here. And they range with different amplitudes. Wave height. Remember, wave height is double the wave amplitude. And in this case, you notice there's no concentric circle in this particular diagram, but then the scale is given, so it is 10%. So seems like this length here is about 10% if we measure from the center. Okay, so we use the scale to read how many percent of the time the wave has what wave height and is coming from what direction. Now the wind rows and the wave rows can be compiled for a specific observation period. It can be compiled for the annual observation, and it also can be compiled for monthly observation. For example, a wave rows for different months of the year. The Beaufort wind scale is used to define the different category of wind. For example, here what we are looking at is the scale ranging from 0 to 12, 0 for calm, 1 for light air, and so on until 12 is basically a hurricane. And each of these different category of wind is defined accordingly based on their velocity, whether it's measured in terms of meter per second or knots. Now there's this figure here which allows us to also convert the wind speed to wind pressure. So we have a curve over here which is the theoretical correlation between the wind speed V and the wind pressure P. Now of course these are based on large number of observations, and in some cases when we need to carry out design, then for conservative design we may actually increase the wind velocity by 20% in order to read a higher value of wind pressure for design purposes.